Okay. In return for a loan of £100, a borrower agrees to repay you £110 after 7 months. Calculate the force of interest per annum for the transaction. This question is from Stephen Garrett's book, which I used before. So let's see how we're going to solve this problem. Well, the first thing we have to do is we have to calculate the interest that the borrower is paying. In this case, the interest will be equal to the amount that they will pay, 110, minus 100. So the amount that they were loaned, 100. The amount they were loaned, subtracted from the amount they will pay. That will give us the interest. And I think that we can see that that's, equal to 60. Yeah? I mean, well, no, we'll do that next time. Well, no, let's do that now. If I just save that, then if I go here, I can reload, and if I then type interest, oops, I get 10. Oh, that's because it is 10, sorry. It's 110, 170. I beg your pardon. So yes, the interest is £10. So it's £10 interest. So we have to find out the force of interest. So let's first find out the effective rate of interest for transaction. Yes, what we are saying is effective rate of interest is I. So we have that if we did value of I of 7/12 of 110 at 100 times 0, that should be equal to 110. So we basically, what we're saying is that after 7 months, or 7/12 of a year, 100 now would be equal to 100. Now it's 100 times 0 would be equal to 110. That is for the effective rate of interest I, which we want to calculate. Now remember the definition for a value. Value of I of B of X at T is equal to X times 1 plus I to the power of B minus A. Instead of doing T, let's do A. Yeah? So that's our formula. So that means that if we want to work out the effective rate of interest, now what we have is we know that the value of, in our case, we have value of 7/12 100 0 is equal to 100 times 1 plus I to the power of 7/12. That's right. So now what we have to do is we have to rearrange this. So let me bring this down here like that. Now we know also that this expression here is equal to 110. So what we have, here, we have 110 equals 1000 times 1 plus I to the power of 7/12. So that means that 110 over 100 is equal to 1 plus I to the power of 7/12. which means that 110 over 100 to the power of 12 over 7 is equal to 1 plus I, which means that I equals 110 divided by 100 to the power of 12 over 7 minus 1. Okay, so if I I'll just put that there. So let's see what I is. Compile that. I'll reload I 0.177. So that means that it's 17.7% or 17.749% if you want to 5 significant figures. That's great. So that's what I is. That's the effective rate of interest compound per year, compounded yearly. Or it's the effective rate of interest, which is the same as the rate of interest per year, compounded yearly. So but we were asked for the force of interest. So how do we arrive at the force of interest? Well, we use the following formula. The force of interest, given the effective rate of interest, or the rate of interest per year compounded yearly, the force of interest is equal to the natural logarithm of 1 plus I. Okay, so let's see what that looks like. Force, oops, to reload, and then I'll do force I. That's 0.1633 or 16.339% per year. So that's our force of interest. The force of interest, by the way, is the rate of interest per year compounded continuously. So it's like, imagine if this is, of course, it's a theoretical thing, but it's like if at every, if you could continuously put, instead of doing it discretely, so every year or every month or every day, if you could do it continuously somehow, yes. So not even every second, but less than, you get the idea. Then that would be what it would look like. It turned out that for certain calculations, for example, if instead of compounding per day, if you used the rate of interest compounded continuously instead of the rate of interest per year compounded continuously instead of the rate of interest per year compounded per day compounded per year, instead of the rate of interest per year compounded daily, yes, if you use instead the rate of interest per year compounded continuously, then it makes a close approximation. But we'll see in future videos how to use that. But for now, the important thing to understand is that given the rate of interest per year compounded yearly, the rate of interest per year compounded continuously is the natural logarithm of 1 plus I.